Okay, let's take another look at the penguin problem. And now I don't know that it's actually a penguin, I just call it a penguin. But the problem goes like this. There's a plank attached to a wall and supported by a string at an angle, and a penguin is on the plank. Why is a penguin on the plank? There's no way to know why that penguin's on the plank. Okay, but you need to come up with some reason for why that penguin's on the plank. The penguin is walking out to the end of the plank, and at some point, the tension in the string becomes too large and the string breaks, the cable breaks. So the question is how far, if the maximum tension in the cable is 204.7 newtons, which I just picked, not technically, how far could the penguin go before it breaks? So I did this problem, and I'll link down below with the solution, but here's the end of the solution. I use the net force in the XY and the net torque all to be 0, and I can solve for that distance at which the cable tension is the value of the maximum tension. At that point, it breaks. I also made a calculation of this, and this is actually how I solved the problem. I picked a value for the position of the penguin, and then I've calculated the tension, and that's how I knew what value to calculate. But what if I want to look at the tension in the cable as a function of the distance the penguin moves? So I can put the penguin at 0 and then calculate the tension, and then move the penguin again and calculate the tension, and that's what I'm going to do in Python. So we're going to make this graph of tension as a function of penguin position. So to do this, let's do this the easy way. In GlowScript v Python, I can say f1 equals g-curve. So f1 is just a name I picked, but g-curve is a built-in function in Python that allows you to make a graph. And if I do something like this, f1.plot 1, 1, f1.plot 2, 2, this will make a graph. So this will plot a point 1, 1 right there. This will plot point 2, 2 up there. You can't see the whole graph. But so I can plot as many data points as I want. And that's how this works. See, it's very simple. So what I'm going to do is let's change this distance to 0. And let's calculate the tension, and then move the penguin and calculate the tension, and every time make a plot on the graph. So the first thing I need to do is pick how far do I want to move the penguin each time. So I'm going to call this ds, and let's just say 0.1. It can be whatever I want. Now I'm going to make a loop so I can calculate the tension each time. So I'm going to say while s is less than L, because once the penguin gets to L, that's the end of the plank. I don't want to calculate the tension anymore. You could actually go further because the code doesn't care. Then the way these loops in Python work, if I put a colon and then everything that's tab indented underneath that while statement is done until that while statement's no longer true. So I'm going to go ahead and tab indent this right there, and then I calculate the tension. I already did that. I already calculated the tension. I did that from my previous program. Now I'm going to add a data point, f1.plot. The x value I want to be is s, and the y value I want to be is t. Now I need to increase my penguin distance. So I'm going to do that like this. So s equals s plus ds. This says take the value of s, add ds, and make it the new value of s. It's not an algebraic equation. Okay. I think that should work. Let's just see what happens if it does indeed work. I should have saved it. There you go. So you can see here at 2 meters, I get 205. So I get the same value that I got before. But as the penguin gets further and further away, the tension increases up to a maximum tension of 290 or whatever that value is. Okay, let's make this a little bit better. I want to put labels on my graph. So I'm going to say tgraph, it can be any name, is an object of type graph. The x title is going to be equal to position. I'll just call it position. You could call it penguin position if you wanted to, in meters. And then the y title is going to be equal to the tension, cable tension, let's call it, in newtons. now if I do this, the graph will look a little bit better. And it's super slow. There we go. So it looks better. Okay, so you can see how useful this will be. Now let's do one other thing. What if I change the angle of the cable, just for fun? So I have the cable at 50 degrees. Let's put it at 30 degrees, and let's move this up by a degree. And so now I'm gonna pick the penguin location at 2 meters. I don't care about that. So now this x graph is going to be the angle theta in degrees. So down here, I'm going to have the same calculation. But now I want to plot theta in degrees. So I need to change this 180 divided by pi, change it back to degrees. And then I don't want to increase s, I want to increase theta. And I'm going, I need to do this too. And then I want to do this while theta is less than, let's say, 90 degrees. So 90 times pi divided by 180. And let's run it. And I don't know why everything's so slow. But I'm waiting this out. There we go. Check that out. So here at a very low angle, the maximum tension at that position increases. If the cable is straight up, the tension gets very low. Okay, so this is another cool graph. And you can see how you can change around things in the problem. You don't just get one answer, you get all the answers. And you can vary things up and see what goes on. And the code's not so bad, right? And I'm going to link to this code below. And you can edit the code and run it yourself. And it's going to be great. So you should try that. There you go. That's the parameterization of the penguin problem. I will talk to you guys later.